In section 8.4, we're working with the graphs of ellipses. So we're going to learn how to graph ellipses and how to write equations of ellipses. We have key vocabulary that we're going to discuss here in a moment, the ellipse itself, and its various parts. It has foci, it has vertices, it has a major axis that passes through the vertices and the center. It has covertices, and it has a minor axis that passes through the covertices in the center. So we'll talk about that more in a couple of seconds, but a lot more parts here in the ellipse than we talked about with the circle. If we look at how we might apply this concept of the ellipse, we're told that when lightning strikes an elliptical region where the strike most likely hit can be identified, so it's elliptical. Suppose it's determined there's a 50% chance that a lightning strike hit within an elliptical region such as this. Write the equation of the ellipse and find the area so we know how much of the city was potentially affected. So we're going to finish our section with this by working with this idea of the ellipse. But first let's get in and talk about all these different parts. So first off, an ellipse is made by these two foci. Okay, and the foci, the center would be here. The distance from the center to each focus is the same. And every point on the ellipse is the same sum of the distance from the two foci. So if you take d1 plus distance 1 plus distance 2, for each of these different points on the ellipse, they will always add up to be the same. So for instance, then if I want to draft an ellipse, if I take a string of a certain size and I fasten it to the points of my two foci and put a pencil through a loop, I can draw a very good ellipse. If we move on and look at some of the other parts, again, here's our center. This one is a horizontally oriented ellipse. This one is vertically oriented. You'll find that you don't really have to memorize which one's which. It just sort of works out for you if you just follow some simple instructions. If you look the long way through our ellipse, we'll find that the points furthest away from center, the long ways through, are called the vertices. So we have two vertexes in each ellipse. So we've got foci and the center, and you'll notice that the center and the foci and the vertices are all on the same line. And that line is called the major axis. So the major axis passes through the ellipse the long way. Okay? Now we also have covertices. They're the furthest distances from the center going through the ellipse the short way. Right? And again, we have a center. Now, you'll notice that the covertices in the center are also on a line, and that line travels through my ellipse the short way, and it is called the minor axis. So as we graph, we're going to identify the vertices and the covertices, their distances from the center. So first we find the center, then we identify the distance from the center to the vertex, and the distance from the center to the covertex, and we do that in both directions. That way we get 4. We'll identify our focus, and then we'll sketch in our ellipse. So let's go ahead and take a look at the equation of an ellipse. The equation of an ellipse is essentially the equation of a circle, but it's a circle that has been stretched in one direction or another. So if you think about a circle, if you thought about the vertices and the covertices, those are all the same distance from the center, and that we call the radius. But when I start talking about an ellipse now, the distance in one direction is longer than the direction in the other direction. So my circle has eventually been stretched in one direction, in this case right and left. And that stretch happens because the values for A and B are different. Okay, so now when we work with the equation, the full equation of ellipse, we have H and K. That's still my center. My center is at H, K. And A is the distance to the vertices, and B is the distance to the covertices. Okay, so now it's really, you could sit and you could memorize these two different forms of the equation. One is horizontal, one is vertical. This one is horizontal, that one is vertical. But the key thing is, whatever is A, right? I don't necessarily have to know which one is A and which one is B, though A is always the bigger of the two, right? I know that I'm going to take A and I'm going to graph it in the X direction. That's going to be right and left. And I'm going to take B and I'm going to graph it in the Y direction. That's going to be up and down. So what's important for you to remember is that the denominator is going to end up, that distance will be graphed in the direction of what's above it. Okay? And that way it will just sort of work out for you as you go through and do it without memorizing a lot of formulas that aren't important. It's more important that you stay focused on what do these values represent. And what they represent is they represent how far we travel from the center. So let's take a look at doing this. Right? In this case, I can see again that h is 0 and k is 0. So that means that my center is at hk, which is 0, 0. And if I take a look at my denominators, I know that I'll have the square root of 9. So this is 3 squared, and this is 7 squared. Now, I know that 7 is A and 3 is B because 7 is bigger. But like I told you before, I don't necessarily have to stay focused on that information. I know that I'm going to move 3 in the X direction. 1, 2, 3 to the left, and 1, 2, 3 to the right. So I've moved right and left 3, and I'm going to move in the Y direction, that's up and down, 7. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. Okay, and this is the shape of my ellipse. So I'm going to go like this, and I can draw my ellipse in now. I don't really need the foci to do that, but now I need to find my foci. Now, you'll notice that the foci, so let's talk about some ideas. If my vertexes are here, my foci, you can tell, is closer to the center than the vertices are. And I can always find my focus by using this equation here. C squared, where C is the distance to the focus. It needs to be less than the distance to the vertices, so it'll be equal to a squared minus b squared. So this is not the Pythagorean theorem, but it's very close, right? This sign is different. So if I go through and find the distance from center to focus, c squared will be equal to 49 minus 9. So c will be equal to the square root of 40, which I would call 2 root 10. Okay, but the square root of 40, what is that exactly? Well, it's between 6 and 7. So it's bigger than 6, it's less than 7. 1, 2, 3, 4, 5, 6. It's way up here and way down here. Okay, so I know that if I want to label things, I know that my vertices are at 0, plus and minus 7. My co-vertices are at plus and minus 3, 0. And I know that my foci are at 0, plus or minus 2 root 10. Okay? So that's going through the process. And remember, A was the distance from the center to the vertex. B was the distance from the center to the co-vertices. And C was the distance from the center to the foci. Okay, so again, we may get some of these guys that are in slightly the wrong form. If you look back at the equation, you notice that my equations always equal 1. So when I'm not in the right form, I have to do what will make it equal 1, which in this case would be divide everything by 144. Okay, so when I do that, I know it's going to equal 1. but I need 144 divided by 16. That's equal to 9. So I'll have x squared over 9 plus, and then 9, obviously if 9 times 16 is 144, then this one's going to be 16. And now I have my equation in the correct form. I see that h is equal to 0 and k is equal to 0. So my center is at 0, 0. I know that I'm going to go from 0, 0, and I'm going to travel in the x direction 3, 1, 2, 3, 1, 2, 3. I'm going to go in the y direction and travel the square root of this, which would be 4, 1, 2, 3, 4, 1, 2, 3, 4. So this is much closer to a circle. That's a pretty sloppy ellipse. Let me draw it again. There we go. And now I want to find my distance to my focus. I know that c squared will be equal to 16 minus 9. So c will be equal to the square root of 16 minus 9, which is root 7. Okay, so how much is root 7? Well, it's more than 2, but it's less than 3. So 1, 2, it's right about there. 1, 2, 3. So my foci is at 0 plus or minus root 7. My vertices are at 0 plus or minus 4, right? And you'll notice that the x-coordinate on the foci and the vertices will always be the same. It doesn't matter, in this case it's 0, but when it's not centered at 0, 0, they'll still be the same. And then the co-vertices are at 3 plus and minus 3, 0. Okay, so let's take a look at one of these when it's not centered at the origin. So I know in this case h is equal to negative 2, k is equal to 2. So if I go negative 2, 2, there's my center. My center is at negative 2, 2. Okay, now that means that my vertex will have negative 2 as its x-coordinate. Well, actually, I don't know that it will be the x-coordinate yet. So if you take a look at this item, I want to travel the square root of 16, that's 4, in the x direction, 1, 2, 3, 4, and 1, 2, 3, 4. And I want to travel the square root of 36, that's 6, in the y direction, 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, 5, 6, and this will create my ellipse. Okay, I did pretty well with circles. I'm having trouble with ellipses. Maybe that's because I used the circle tool. Okay, so again, vertically oriented, so I do know that my x-coordinate will be the same for my vertices, and that means it will also be the same for my foci. And how much did we move? We moved 6, so not negative 2, we moved 6 from 2, so 2 plus 6 is 8, 2 minus 6 is negative 4. Those are my locations here. If you look at the co-vertices, they're going to have the same y-coordinate as the center. And from negative 2, I moved 4, which would take me to 2, and minus 4, which would take me to negative 6. And then I want to find the distance to my focus. So c squared will be equal to 36 minus 16. So c will be equal to plus or minus root 20, which would be 2 root 5. So over here, I'm going to take 2 root 5, and I'm going to add it to 2. So it'll be 2 plus 2 root 5. And here it'll be 2 minus 2 root 5, because we moved in each direction. Okay, you could make this into a decimal if it made you happier. That would be fine. Okay, so 2 root 5, square root of 20. It's more than 4, less than 5. 1, 2, 3, 4. 1, 2, 3, 4, and a bit. There we go. Those are my foci. So my covertices, my vertices, and my foci. Okay, so the key thing for you to remember is that when we're finding these values for A, B, and C, they're distances from center. If you take a look at this little piece of information, this implies that they're just numbers you plug into ordered pairs. That's not true. The only reason this works is because we're moving from 0, 0, and when I take 0 and I add and subtract A to it, I get plus and minus A. But you can see in this example, that's not what I got at all. Right? So don't get confused by this piece of information here. Just stay focused that A, B, and C are distances from center. So go ahead and practice graphing the ellipses. Do problem 6 and 9 from 8.4 and problem 10 from 8.6. And then come on back and we'll write some equations. So if I want to take these items and I want to write them into an equation, I have a center at 0, 0, so I know I'm going to have x minus 0 squared. I always have a plus here, y minus 0 squared, and I know it's going to equal 1. And then I have to take a look at my values and think about when I moved from center, what direction did I move? Well, if you look for my vertex, I moved from center and I moved up 12. Okay, so that means that this was related to y, 12 squared. And the covertex moved left and right, moved right 11, so that would be 11 squared under the x direction. So this is x squared over 121 plus y squared over 144 equals 1. So by looking at how I moved from center to here, that allowed me to both identify A and know which variable did it go under, because the direction tells you where it goes. Okay, if I take a look now at this problem, I have the same thing where I have x minus 0 squared plus y minus 0 squared. It's going to equal 1. So we know we're at the origin, so I put in h and I put in k. Now, when you look at the vertex, I moved from 0 and I moved down 4. So down is a y move. So this is going to, and the distance was 4, so I get 4 squared. And now they gave me the focus, so I don't know what the b value is, but I do have the c value. So I thought that negative 2 rad 3 squared will be equal to, this was the a, it will be equal to 4 squared minus b squared. And if I solve for this, I'll get b squared. So this is going to be negative 2 squared is 4, root 3 squared is 3. This is 16 minus b squared. So I'm going to add b squared to either side and subtract 12. B squared is equal to 4. So then b is equal to 2. Okay, if we go ahead and simplify this, this is x squared over 4 plus y squared over 16 is equal to 1. Now in reality, you'll notice b squared is what I wanted, so if you wanted to go straight to the to writing the final equation, the simplified equation, you don't really have to square root it and then square it again. Okay, let's take a look at this when it's not centered at 0, 0. And I think it's helpful to sort of sketch a picture because it helps us to understand what's going on. So I'm going to grab a graph here really quick so that I can draw a good picture of where all these points are, because it's going to help me understand what's going on. So at negative 3, 4, 1, 2, 3, 1, 2, 3, 4, I have a vertex. And at 5, 4, 1, so 1, 2, 3, 4, I'm sorry, 1, 2, 3, 4, 5, 4. So if these are my vertices, then you know this is a horizontally oriented ellipse. And I know that my center is halfway between these. So if I find my center, I know that it's going to be the midpoint between these guys. So we could use midpoint formula, right? 5 plus negative 3 divided by 2. And then we'll have 4 plus 4 divided by 2, but obviously that's going to be 4. And I know that because I'm moving in the horizontal line. 5 and negative 3 is 2. 2 divided by 2 is 1. So my center is at 1, 4 right here. There's my center. Okay, so for right now, I have my center at 1, 4. That means that I have x minus 1 squared. I'm going to build up my equation here. And y minus 4 squared because I took h and k and I put them in as h and k. Okay, so remember, x coordinate goes here and the y coordinate will go here. Okay, so now let's take a look at what our distance was from 1 to 5, right, would be 4. So I know that a is equal to 4, and I moved in the x direction, so that's 4 squared. Now if I look at my foci, negative 1, 4, and 1, 2, 3, 4, right, so I know that this distance here, right, remember we looked at the distance from the vertex to the center, that was 4. The distance from the focus to the center, that's 2. So I know that 2 squared is equal to 4 squared minus b squared. So I'll have 4 is equal to 16 minus b squared. If I add b squared and subtract 4 to either side, b squared is equal to 12. So I can just go ahead and put b squared is equal to 12 right there. I'm going to change the 4 squared to be 16, and I've written my equation. And what you should notice is, by sketching this in, it made it very easy for me to find the distances. This is A, this is C. I saw that it was all horizontally lined up. The vertices and the co-vertices, the vertices and the foci were all horizontally lined up. That meant it was a horizontal ellipse. I made my horizontal move. I took the distance and I squared and I put it under x. And that let me write the equation. So go ahead and practice writing these equations. Do problems 26 and 29 from 8.4 and 18 from 8.6. Come on back and we'll find out about that lightning strike. So if I want to write the equation of my ellipse, let's take a look at what's going on here. So I know that here's an ellipse and I've got a center here in the middle, and I'm going to say my center is at 0, 0. So you can see that if my distance from covertice to covertice is 200, that means that this distance here is 100. And this would be my b value. B would be equal to 100. And I know that this distance here, right, so that was this distance here was 100. And that means that this distance here is half of the 400. That's 200. So I know that A is equal to 200. And that's all I need. If I go ahead and write the equation of my ellipse, this is horizontally oriented. I can see that for sure. I have x squared over 200 squared. The 200 goes here because it's the horizontal move. Plus y squared over 100 squared. That was the vertical move to the covertices, and it's going to equal 1. That's that. If I want to find the area of the ellipse, it's A, my area is going to be 8 pi times A, which is 200, times B, which is 100. So this is going to be 200 plus 2 zeros, so 200, 0, 0, 20,000 pi is equal to my area. If I wanted to find that as a decimal, which I might, I could take 20,000 and multiply it times pi, and I get 62,832 essentially. And this is meters, so that would be meters squared for area. Okay, so that's working with ellipses. In our next section, we're going to take a look at hyperbola.